there are lots of different things that can impact the performance of the internet connections. It could be traffic, obviously, because it can be congested, but it could be errors, can be discussed, could be QoS policies, could be, I mean, at some point we will need to know the actual traffic, we will need to analyze the traffic going through the interfaces, can be the routers itself with the CPU, with the memory. There are so different things that can impact the performance and the quality of the links that we need to monitor these connections from a holistic point of view. And this is what we're doing on this report. So to start the demo, we're going to say is that imagine that in the last 48 hours, people has complained that at some point the Microsoft Teams application was running with issues. This is a typical situation where you have a SaaS product, in this case it's a cloud offering because it's Microsoft Teams that is in the cloud, and you don't have too much control of the performance. If there's any problem with the performance, you don't have too much control on what you can check. So one of the main things that we can check when we have performance issues in applications like that is the status of the internet connections. But as we mentioned, maybe it's not only congestion, maybe it's not only errors or discards. There can be lots of different things that can impact that application. So what we'll do is we will go ahead, change this to the last 48 hours, just to make sure that we catch the issue. And then before we start, just mention the different areas that we have here. Because as we said before, there are lots of different things that can go wrong. It can be the connections, the actual congestion of the interfaces, can be errors, discards, or maybe it can be even the routing protocol. We can be using BGP, we can be using ISIS. Maybe some of them are down for whatever reason. Maybe it can even be the actual performance of the link at the provider level, that we need to check if there is jitter, if there is packet loss, if there is a lot of latency on those connections. Obviously, when we need to analyze the traffic or the actual bits per second, we need to know the actual applications, the top talkers that are generating this traffic. And also, as we mentioned, QoS, the actual routers as well, with the CPU, the memory, the availability, all these things can impact the performance of the applications running on the internet. So here is just to show that we are getting data from lots of different sources, because when we start troubleshooting this issue, we will need all this information to understand why this is happening. But let's go ahead, let's go back to the main page here, and then let's focus on the issues, okay? So what I can see here is that, for example, I have some issues here with QoS. I will review that later. I can see some issues with the quality of the link. As I can see that we have some peers that are down. I can see here some congestion. I can see as well. And also can see here some of the quality of the link. So basically these are IPSLA operations, and this is telling me that the quality of the link is not great. So I'm going to start from there because I can see several of these alerts. I'm going to go to this app and see why this is happening. So yeah, when you come here, you will see that, yeah, I can see that here at some point that the MOS is quite bad. But what is MOS? Because maybe we talk about latency, we talk about packet loss, people understand that, but MOS, people maybe doesn't understand that. That's not a problem. Here in SevOne, we can add these widgets where we can explain, we can add any kind of content. We can explain the feature, we can explain the meaning, we can put contact details that in case that something happens, who to contact, any kind of annotation to make our life and the operational guys, the life much easier. So I can see here some issues. Okay, that's fine. But why is this happening? Well, what I'm going to do is go back because I saw that we had an issue with the traffic, and let's see if there is any kind of correlation between those issues and the traffic. And actually, yes, you can see here that at this time, it looks that we had the same issue. Actually, just to make sure that these correlate, let's go to the instance workspace. Let's put the objects together. I think it was this one as well. And let's check the MOS. Let's check the traffic. This one, for example. Actually, it was not this one. It was the other one. I always get confused. It's the San Francisco one. And then, oops, sorry. Let's get the MOS. And let's get the traffic. And yeah, here you can see a big correlation that in some points, in some situations, this is happening. This is very interesting that when we have these spikes. However, in other spikes, we don't have this issue. Why is that? Maybe it's because of the application that we're running. How can we check which is the application running here? Well, here we have the option to show metric and flow in the same report. So let's go to flow. Here you can see the users, the actual IPs generating the traffic. Let's change the view to show me the applications. As you can see, everything in real time in the same report. You don't have to change anything. Here will give us a much more information. For example, I can see that this spike that we have here is mainly Netflix, whereas the other spike that we have here that is actually generating the issue is the SQL. So actually, look, every time we have an SQL, spike of SQL traffic, that actually looks kind of common, kind of normal. If it looks every day at the same time, we're having issues with first of all, we have the link congested, but also we have issues with the actual performance of the link. So here we have identified one problem. The thing is that I don't see that every day, or at least the feedback I got from the team is that it's not always every day at the same time we're having issues with the Microsoft Teams. So possibly this is another issue that we have identified. Is not the same issue that we saw before. So that we are trying to troubleshoot. That is the Microsoft Teams issues. But at least we have found out that because we have these backups running at 9 a.m. or 10 a.m. every morning, that's why we're having bad performance and we have congestion in the team. So now we can go back to the team that creates these backups of SQL and tell them to change the configuration so it doesn't impact always at the same time during the day. That's fine. We found an issue. That's great, but this is not the issue we were checking. So let's go back here and let's have a look which are the other alerts. And the other most important alert is this one here, that is that we're having some QoS drops. Actually, this is a priority queue. It's not a best effort, because if it was a best effort, we wouldn't worry about that because, okay, we have queue drops in the best effort queue. That's not a problem. If we have drops on a priority queue, that's a problem. So let's go ahead and go to this section. And first of all, you will see that, yes, actually we have this blue line, that is this one, that is the best effort class, that is not generating any alert, because again, we don't want to receive alerts when the best effort class generates drops, because that's normal. That's the way we can configure the network to have this. It shouldn't be a problem. And actually you can have lot of them, but also you can see this one, the priority class. And actually this was here, you can see a spike of a packets drop. It's not always, as you can see, it's very occasional. You have it here. And actually this correlates very well with this one, the yellow line that is actually is the same class that we have here. So I can see that it looks that there is a specific spike of traffic here that is generating this, this spike of packets or bytes drops. But how can we know what kind of traffic is generating this? How can we have this information here? Well, what I would do is go to the internet connections and let's see more or less at the same time if there is any spike. And look, it looks that there is a little spike here, but when you zoom in, what you will see is that this spike changing, and look, is quite high. So actually there is a massive spike, a big spike here. But if you look at the times, look how long it takes. It takes seconds. How can we detect something in seconds when actually normally what we do is monitor every 5 minutes? Well, this is using our amazing high frequency polling feature that allows us to monitor some objects, some KPIs up to every second. In this case, and actually as you can see here, we're monitoring this specific object every 10 seconds. We could change it to any other value, 10 seconds, 30 seconds are normal values. It can be up to 1 second, but obviously we have to be conscious of the impact that we will have monitoring at this space, that object on that device. But you can see that, yeah, there is a micro spike here. So actually, we should review why this is happening. What kind of traffic is this? Well, let's go again to the bandwidth analysis section, and let's see what kind of traffic was generating that spike. And if you zoom in here, actually, you can see that there is a specific traffic that is generating more traffic. This kind of blue, green, actually nice blue application. And look, it's actually the Microsoft Teams application. So actually what is happening is that we have matched a Microsoft Teams application with the priority class that we saw before in QoS. But as there is a spike of traffic that we saw before, it's a massive traffic, what is happening is that we are going over the bandwidth assigned to that class, and that's where we start having drops. That's the performance issue that people were mentioning before to us, that in the last 48 hours, they had issues with this application. And it's because of this. Too much traffic of this application, we don't have the QoS policy configured properly, we're having drops, and people have a bad experience with the application. How do we solve that? Well, the way we solve it is changing our QoS configurations in order to accommodate these micro spikes, micro bursts of traffic for this type of application. Once it is done, people will stop having performance issues on this application. But before we finish, I wanted to mention something very interesting. This feature of high frequency polling. This is very interesting because look at this. For us, it has been very simple to identify that this was a problem because we saw the spike. But actually, I know that we have the same type of traffic in another office, on the San Francisco office, where we have the same, exactly same traffic. We have the same issues with Microsoft Teams, but on this office, we don't have this high frequency polling feature enabled. So how will we see this differently on this office where we don't have this feature enabled? So let's go to that office. Let's go both internet connections here and here. Let's show the total traffic here and here. And look at the difference. Whereas in the Chicago office, the blue line, you can see that there is a massive spike, and this is a problem. Look at the San Francisco office. It's just a little higher traffic than normal. This is a problem because if we saw this, we would never know that there was a microburst or a spike of traffic at this point in time. That's why this feature is so valuable, because this tells us if this gives us the granularity that we need to identify this kind of issues. If we were checking in San Francisco, as we didn't have this feature enabled, because you can see it's monitoring for 5 minutes, we wouldn't never know, or it wouldn't take much longer to identify this issue. But as we have this feature enabled here, it took a few minutes to identify this problem. Finally, as usual, something I would like to know is, okay, is this happening always at the same time, these spikes? Is this something normal? Because maybe that will change the way we configure our QoS. Well, in SevOne, as you guys know, we have the data analytics workspace that allows us to understand the normal behavior of the traffic. And yeah, as you can see here, yeah, this is not normal. The traffic normally is at this space. This is not normal. If we change, for example, this to the last 24 hours, you can see that yeah, the spike here, actually we go a bit higher here. Yeah, it follows more or less. There can be little spikes, but that spike that we had at that time, last 48 hours actually, yeah, is not something normal. It just happened at this point in time. So now with this information, we know that this is a sporadic spike of traffic, that this doesn't happen always at the same time, the same day, but that this is impacting our QoS policy. Therefore, we should change the QoS policy to accommodate these spikes of traffic and make sure that the people using Microsoft Teams have a good experience. That's all for today. Thank you guys for watching. Thank you. Bye.
When we start, we can see here that we have 300 alerts. And actually, sometimes we're going to have to do this. Let's change to the last 24 hours to have more data. And then you will see that we have 540 alerts triggered. There are a lot. So what we have to do is, if we want to start troubleshooting what is happening, we have to start with something smaller. So what we can do is go to device groups and then go to priority and filter only for P1 devices. Now we're going to have a smaller number of alerts, 148, so we can start troubleshooting the alerts. So let's start with the most severe alert. In this case, is this one, is the Chicago firewall connections, the number of connections is lower than 50% of the baseline. So it looks that we have less connections than we expected. Okay, let's troubleshoot that. How do we do that? We start from a high-level view, then we start with the workflows. We drill down to more specific views. In this case, for the device, we have two options. We have the network device summary, and also we have the Cisco ASA device summary. Let's go to this one. Now here, we'll see that this alert is triggered. Also, I can see a bunch of CPU alerts. I will have a look later into that. And I can see here on this graph, actually, I can go to this one here, that is going to see much better, that we had a couple of issues on the number of connections. Okay, so I can see the alert that the number of connections is quite low. I can see here, it's fine. What do we do? Well, let's keep troubleshooting. Let's keep having a look at the other options to see if we can find why this is happening. So we can go through the other tabs. We can see here the connections, everything looks fine. We can go to IPsec. There are no issues. We can go to SSL. Again, we don't see issues. Then we go to CPU. And when we go to CPU, say, look, it looks like we have here 2 spikes of CPU. And actually, remember before we saw on the alerts, there were some alerts on CPU. How can we check if this correlates with the issues with connections? Well, you can click here on the graph, and let's go to the instant graph workshop. Again, we're doing the workflow. We are following a path to troubleshoot the issue. We started from the high-level view, we went to the device view, now we go to a more granular view to try to correlate information between 2 different indicators. So let's click here. This is the CPU. Any CPU would do. You will see that there are CPU 1, 2, 3. It doesn't really matter. All of them are high. What we have to do is add the connections object, because we want to do is correlate both metrics in the same chart. When you select the second object, you will see that the indicator disappear, not a problem. Just select again the 5 minutes, for example, and the current connections. And now you will see here, there is a strong correlation between the CPU going high and the drop in number of connections. And actually you can see here that there's both pretty much at the same time. So we can say that, yeah, is related, the drop of connections due to the high CPU. This is good, we could stop here, but actually say, okay, but why is this happening? Why do we have so much CPU utilization? Well, let's go back, and then you can see that we can click back on the breadcrumbs. So this is very important that you don't lose where you were. You always keep track of what you're doing. And then let's keep going. We can go to memory. That's not really important, but what is important is processes. I want to see which processes are having high CPU. So we have identified in the CPU tab that we're having high CPU. Let's check which processes are having high CPU. And here you can see, yeah, we have here a spike, we have another spike. And actually, if we order this by max, you can see that it's the SSL process that is having CPU issues. Okay, let's see if this is normal. If this is not normal, let's click here and let's go to the data analytics workspace. Because I want to see if this kind of spike of CPU of SSL process using CPU are normal. And you can see here that these are the spikes and they are not normal. We've seen several spikes in other times, but not at the same time. So I would say that this is not normal behavior. This is something that should alert us because this is not expected. Now you can see that we have some spikes here. These over the time they will be removed. The problem is that we started this a few weeks ago. The baseline is still building up, but at some point this will be more even and you will see the spikes much better. This is a good time to show the other options, like show time over time as well, if you want to show the difference between today and the last week, or trends, or projected, not so important. Probably calendar is quite an interesting one. You can change to the last 7 days to see that every now and then, yeah, there are spikes of CPU. So it looks like it's not always at the same time. It looks like maybe it's not every day, but almost every day. So it's something weird in this situation. So I can see that high CPU generated from the SSL process. So what can I do? Well, actually, what we could do is Google why is this happening. So we could do is Cisco ASA high CPU SSL process. And I agree. And you can see that one of the first options that you will see here, it will tell you that this is generated sometimes by DDoS attacks, or very similar, in this case, SYN attacks. Okay, so we have identified that we have drops in number of connections because we have high CPU. The high CPU is generated by the SSL process. And actually here, I go to Google, I can see that this can be generated because of SYN attacks. What can we do? Well, in this case, we also have NetFlow enabled on this device. So we can go to the Flow tab and we see something interesting on the flow data. And here you will see all the interfaces of this device, and then using metric to flow, you can see all the other information, top talkers, top conversations, top applications. Nothing very interesting from this kind of point of view that we're trying to troubleshoot. But if you scroll down, you can see here the denial surveys. And yeah, you can see that at this time, exactly at the same times of the spikes, we're having lots of TCP SYN packets. So it looks like we're having some kind of DDoS attack, or much more traffic at this point in time from this kind of packet, this type of traffic, that is potentially generating the SSL spikes, that is generating the CPU spikes, that is generating the drops on the connections. Actually, just to make sure that is the case, we can go to connections, and from here we have configured the metric to flow. Just select flow, and then you will see the correlation between the TCP SYN traffic packets and the drop on connections. Now that we have identified that this is the issue, and we can work on that, because now here we have all the IP addresses that are generating the traffic, so we can configure our IPS or IDS or firewall to drop these IP addresses. We have solved the first issue. We can go back, we can go to active alerts again, and continue troubleshooting the rest of the alerts that we have triggered.